Across the emptiness of deep space, there are objects so dense that reality itself starts to break down around them. A neutron star is one of them. The densest stellar object in the universe. Imagine taking the mass of our sun and crushing it into a sphere barely 12 miles across. This is how a neutron star is born. A teaspoon of its material would weigh around 6 billion tons. And this star doesn't just spin, it spins hundreds of times per second. This is a place where gravity crushes atoms into pure neutrons, where matter becomes something the human mind can never comprehend. Most neutron stars are packed with nearly twice the mass of our sun. The most massive one we know of pushes even farther, about 2.35 times the mass of the sun. And all of that mass packed into a sphere barely 12 miles wide. That's roughly the size of San Francisco. And here's where the human mind breaks. If you take a single teaspoon of neutron star material, that teaspoon would weigh around 6 billion tons on Earth. That is heavier than the 800 Great Pyramids of Giza sitting on a single spoon. This is not science fiction. This is what the universe actually built. But how does something like this even exist? This dense in such a small amount of space? To answer that, we need to watch a star die. Everything begins with a massive star, one that weighs at least 8 to 10 times the mass of our sun. For millions of years, this star burns, fusing hydrogen into helium, helium into carbon, all the way up the periodic table, until it reaches iron. Iron is where stars go to die. Unlike every element before it, iron cannot release energy when fused. It only absorbs it. The moment a star's core turns to iron, the fusion engine shuts down. The heat that was holding the star up against gravity vanishes. In less than a quarter of a second, the core collapses. Electrons and protons are crushed together with such force that they merge, forming neutrons. The collapsing core bounces back in a shockwave of unimaginable violence, blasting the outer layers of the star away in the most powerful explosion in the known universe, a supernova. The energy released in that single moment is equivalent to what our sun will radiate across its entire 10 billion year lifetime. And what is left behind at the center of all that wreckage? A neutron star. Now here is where the neutron star becomes truly supernatural. If a massive star collapses to a fraction of its size in an instant, it must spin faster to compensate. Not slightly faster, violently faster. A neutron star can be born spinning at 60 times per second. And if it has a companion star nearby, feeding off its material, it can be spun up to over 600 times per second. The fastest spinning neutron star ever found rotates at 716 times per second. That is 24% the speed of light. These rapidly spinning neutron stars that emit beams of radio waves from their magnetic poles are what we call pulsars. On the outside, a neutron star has a solid crystalline crust. Iron atoms stretched into long chains by a magnetic field 1 trillion times stronger than Earth's. The gravity is so intense that if you dropped a marshmallow from just 1 meter above the surface, it would hit with the force of thousands of nuclear bombs. If you go deeper, the density increases beyond anything we can recreate in a lab. The outer layers are already billions of times denser than diamond. At the core, we genuinely don't know what exists. The density there approaches and possibly exceeds the density inside an atomic nucleus. Some physicists believe the neutrons dissolve into their constituent quarks, forming something called quark matter, a state of matter that has never been directly observed anywhere else in the universe. But despite all this power, these objects are scattered across the universe, invisible to our eyes. The Milky Way alone contains an estimated 100 million neutron stars. And every now and then, two of them find each other in the darkness. They begin a dance that will last millions of years, spiraling inward, faster and faster, closer and closer, until nothing can stop them. And then they collide. In a single instant, an explosion so violent it sends ripples through the fabric of space-time itself, gravitational waves that stretch across the entire galaxy. And in that impossible violence, the universe creates something new: gold, platinum, and uranium. This debris of these heavy elements, forged in the collision, spreads across the galaxy. For billions of years, it floats through the void, waiting. Then, when a new planet forms from this cosmic dust, swirling gas and rock coming together in the darkness, the gold becomes part of it. Every single grain of gold and platinum that we have on Earth was created in the collision of two neutron stars. Before Earth existed, before the sun was born, in the most violent explosion the cosmos has ever known. A neutron star is the universe's final act of defiance, a star that refused to become a black hole. And yet, it is out there, right now, spinning in the dark, ticking like a clock, a lighthouse in the void, the densest star in the universe, waiting to be understood.